Okay, so I guess most of you guys know about React hooks, right?
No.
Okay. So, um, I mean, even if you don't know what is React hooks, you might have heard about it like from the React conference last year, or you like saw people are like flipping around like saying a lot of things in Twitter or social media about hooks. So today I'm going to like share with you guys. So this talk will be focusing on like a brief introduction of what you need to know about hooks, and so that you know like why a lot of people are so hyped about hooks, and also as a you will see as this talk as some starting point for you to understand how hooks works, and then you can like research more if you want. Yeah. So a background. I think this was screenshot a while ago. They say React hooks just released, and in version 16.8. And this was screenshot last week. I think right now it's release candidate 2, and they say this new version will have React hooks in it. Yeah. So React Native will also have React hooks. So like how a lot of people talks about hooks. So I trying to like take a Google trend about React hooks. So if you look at this graph, you see like there's two peaks. The first peak is when Dan Abramov shared in last year in React conference, and then the other peak was like recently, like early February, where they just released this thing. And I also like try to see how many people mention about Shopee. It's quite good. But very interestingly, this is from United States. I don't know why they search Shopee there. So yeah. So outline of today's sharing. First of all, we cover like why hooks are so great, and then second part of it will be like all the hooks that React provides. So we'll be brief covering like how they work and what they are for, and then rules of hooks, and then lastly will be a bit of how hooks actually work under the hood. So hooks. Okay. Before everything, right, just a disclaimer, I'm not like a very expert in hooks. I just like read a bit online and articles and also like to come up with these slides. So if anything I've said a bit wrong, you should like come and correct lah. Okay. So so what's so good about hooks? First of all, if you look at the code above, this is how we usually write our simple stateful components, where let me get my mouse. Okay, so where we need states, and then when we click on something, we call setState to update the state. So whenever we need a state in our component, we have to write class components. But with hooks, we have another option. We don't have to write class components. We can use states as like use a hook called useStates, and we can have states in our functional component. So secondly, before that, when we want to have life cycles, we have to write class components again. So like for example, this component where we add we need like to observe something on when the component is mounted and unmounted, we have to write class component. Now you don't have to do that. You can use hooks. You can use you can have this life cycle event in functional components. And if you notice, for this class component, right, it's a bit longer, and you notice like they do a few things in a lifecycle event. Right, so if you read the code like this, right, you need to you don't know like whether like this line is related to which line in the component did mount. When you use hooks, you can group them together, so like in groups. And hooks are just functions, so you can call these functions in you can like abstract this function out as another function, and you just call this function in multiple components, which means that this allows you to share your life cycle events in multiple components. So previously, when we write one component with like component mount and unmount, and we want to use the same logic for the other component too, we have to recopy the code again, right? But now you can just, it's a function, you can just reuse it in multiple components. So thirdly, hooks allow us to reduce the depth of the React render tree. So if you look at this simple component, right, we wrap it with maybe with a hawk, right? And then when you look at in the DevTools, you will see there's one layer like component with such and component. And then when we do like connect or we do render props, we keep wrapping our render trees, and it will be a very nested render trees. But with hooks, you can rewrite the same logic with hooks, and when you do that, you don't have like very nested render trees. So this will in some way improve the performance of React to do your rendering. So this is another example of when you in a render prop situation. So previously was hop, now it's like render props. You can rewrite it in a way that your render tree is like simpler. Yeah. So again, render prop. And so this is just to illustrate again. You can reuse your logics in multiple components. So I've covered like what's so good about hooks, right? So what kind of hooks that we actually have by default when React provides. So you can go to these links to see the full list of what are the hooks. And this is the one I screenshot from the docs. So React grouped them into two groups, like basic hooks and additional. But I'm not going to like cover it that way. I'll be like group them together in how they actually function, and how they are similar with each other. So the first group I have is useState and useReducer. So these two hooks are actually providing states to your components. So let's start with the simplest one. So useState. useState is just a hook that allows your component to have states. And so useState is just a function. So this one, the argument you pass in is the initial state. It can be anything like object, array, or number or string. So it doesn't have to be. So it's slightly different than the set state or the initial state that we have. So this is just the initial state, and then it returns an array of two items. The first item will be the state itself, and the second item will be the set state. So one thing is different about these hooks and the usual set state we have is that when you set this, right, it will just set the state of itself. It's not like merging the partial state. So when you use the object here, right, and you call set state, the entire object will be replaced. There's no merging of states. Nextly will be reducer. So if you have like written Redux code, you'll be familiar with a reducer function. So reducer is like a more, it can handle a more complex set state function. So meaning you can have a logic of setting different state based on different logic that you have. Basically, it's still like a set state where you have state and dispatch. So when you call dispatch with something, that will be the action in your reducer function. So state and action, and then you return a new state that you want. So you can have any kind of logic that you like to return here. So the second argument will be like the initial state, and lastly will be the init function. So if your initial state is a bit complex, you can have an init function here so that the initial state are lazily created. Yeah. So just an example of how you use reducer. So this have nothing to do with Redux. It just looks like Redux because it uses the same logic of reducer. So you don't really need to be like use a object like a action.type or whatever to dispatch. You can just dispatch any kind of action that you like. So for example, if you want to make you still feel like you want to have a set state behavior that we used to have, you can write this kind of reducer where you take a new state and then taking a partial state and then you return a merging of two states. Then this dispatch will behave as what we have a set state right now in a class component. Yeah. So basically, use state and use reducer is to provide states for your component. The next group we'll have is use effect and use layout effect. So use effect and use layout effect is to replace the component did mount and component did update and component will mount. So basically, when you have code like this, where you have a component did mount, did update, and unmount, you can rewrite it this way, where use effect will be called every time you render the component and you return a unsubscribe function, like a cleanup function. So every time you render, you will call this. So it behaves like did mount and did update. And when it tears down, you will call this by, so it will behave like a unmount. So okay. Yeah, so there's a second argument of the use effect, which is the dependency list. Meaning, like, you don't call it. This list will act as a list. So meaning when this list doesn't change, you will not call this effect function. So it feels like what you have here. So if you doesn't change your props like the full, right, then you will don't do this. Yeah, so this will translate to this code. So I think I have one thing that I missed out previously. So this function will get called every time when you call another use effect. So basically the by, so basically on did mount, you will call by again and high. So every time every time this function gets triggered, you will call the tear down function before you call the high function.
Question. It seems that it's not really equivalent to the component will unmount, right? Because every time you render the hook, every time you render the inner by, you will call.
Yeah, so it's slightly different. Yeah, correct. So to summary, use effect, this function will get called every render, and this will be called after you want to call after it's being destroyed. Meaning even after you want to call this again, you will call a destroy function. And dependency list will be the list of items that they will do a shallow compare and prevent you to run the effect again. So if you don't provide anything, this whole thing will be called every time. If you provide an empty list, meaning there's nothing to compare, so it will never be rerun again until you unmount. And if you pass like one item, then you always check that item. So use effect and use layout effect. So I didn't mention about how use layout effect works, but there's only, the code wise it behaves the same. The only difference is when it's being called. So layout effect will get called in the commit phase, meaning when the component DOM get updated, immediately we'll call a use layout effect. So usually you use that for maybe you do some update the state, and then right after you mutate the DOM, right, you want to get the scroll position or whatever and then do something, right, then you will use the use layout effect. Or else you use effect. Because use effect is asynchronous and you will get called slightly later, but it's more efficient and it's more optimized in that sense. Nextly will be use context. So use context is very simple. You just pass in the React context, and then you will get the value. And then when your context change every time, a component will get re-rendered. Nextly will be use ref. So this ref will gives you a ref, and it feels the same as the one that you have in React.createRef, meaning you will have a current. It's an object, and then it has a current key in the object. So if you think that ref is just for DOM references that we used to do, you are wrong actually. So meaning actually they use ref, right, as like, so I think, okay, I will explain that later, but let's go through like how do you use the use ref. So you have this ref. You set, usually when we have in class component, right, we have a this.input ref, right, and then this when you call ref, you set a value to this like an instance variable of the component, and then when you want to do something, you call the instance variable of this component to do something, right? So if you look at it this way and you abstract it a bit, use ref can be anything, as it's just like it doesn't have to be DOM references. It can be anything, as long it can be any instance variable. Yeah. So like you have this kind of scenario, this interval, and then you do something with this, right? You can actually use ref in a functional component. Yeah. So you can actually write it this way. So use ref can be thought of instance variable. It doesn't have to be just DOM references. Because anyway, when you use it as DOM references, you set it in the instance variable of the class, right? So if you think like generalize it, it's just an instance variable. So next group we have is callback and memo. So callback and memo is to so just to explain how it works, callback will take in a function and a list of dependencies, and so memo will, the dependency list will work the same as use effect, and then callback, and then use callback will return a memoized callback function, a memoized version of this. So basically the first time you call, this function will be returned, and the next time you call with the same list of dependencies, the previous function will be called. Because sometimes when you write this, you write it this way, where you inline the function itself. So you don't want to return a new function every time, because every time when you execute this code, this is a new function. You inline the function, right? So if you don't want to return a new function every time, so as you use the use callback and that function, so you will only return a new function when the dependency list will be different when in the next render cycle. Use memo takes, so these two is actually the same. It's just that this function is a factory function, meaning use callback return this callback function, right? The memoized version of this callback function. But use memo will call this function and return the return object here. Okay, I think it's a bit, it's a lot of information, and if you don't use it, you don't like feel how is the difference. So basically, this is how it works, and you might need to like play around with it a bit to like get the feeling of how it actually how it works. So sometimes they also use memo to get like a instance variable of the component. So like this code, you can actually like loosely translate it to this when you want to write it in hooks. meaning, okay, so let me like go through with you like how this code works first. So in this component, every time you did mount, you create a new indexer, like a new item, a new instance. And then when did update, when items has changed, you create another new instance. Okay, so basically this is it. And when you write, you want to translate this to React using hooks, you write use memo. So this list, right? Whenever this list, which is items, change, you will return the return object of this function. So every time that list changes, you will return new indexer. If it's not changed, you will not return. Yeah, basically that's how this translates to this. Next, I have imperative handle. I'm not really sure how this is being used, but from my so this is actually to provide an instance method to the class, to the component. So previously you have a class component and you have method, right? Now if you are writing this component as a function, how do you get the method for the component itself? So because they try to like provide every right now like all the things that we can do with class component with something of hook equivalent. So they provide these hooks called use imperative handle. So this and returns an object called this one. This will behave as like this. Yeah. And the last hooks we have is use debug value, meaning you just pass in something and then you can see that in your DevTools. Okay. So hooks, right? So what are the rules of using hooks? Things some of you might have known already. So basically, there's only two rules. One is that you can only call hooks at the top level, meaning you cannot call hooks in loops. You cannot call it in nested functions. And you have to call it in sequence. So why is that so? I think I will explain it later on, and like on how hooks actually works under the hood. And next also, in a React component, when you do render, you only can call hooks in there. So there's a ESLint rules to prevent you. So you can only call, so that will check whether when you call use something, they assume that's a hook, and you can only use that in a render function. So how do they know? They will check whether the function name is Pascal case. Yes, that's how they know. So it's like a convention. And you can also call hooks from hooks. So you can like compose hooks, right? You can write a hooks that cause multiple hooks. So how do they know that that function is a hook? They just camel case and it starts with use, USE. That's the convention in like the ESLint plugin. So, okay, lastly, hooks in there. So how does hook actually works? Okay, so this is like a random component. I don't know how it works, but you just need to pay attention that there's three hooks: use state, use effect, and use memo. Okay. So the code is here. So we'll try to render this function. So when we start to render this, it's the component called full bar, right? So this is the very first time we render. So we create so for all components, right? This is the first time we have this component. React will create a new fiber component for it. So what's fiber? Fiber is just like a way how React, a data structure, how React stores information of that component itself. And every time you render, you will take some like previous information from that data structure to know like, oh, something has updated or something has changed. So React create this fiber instance, and then if you go to like the source code, you'll find this variable called currently rendering fiber. So when you call a render so when it's rendering, this will actually point to this fiber node. Okay. So next, what happens is then you try to render this component. So you will point like, okay, start from here, right? Like step through the code. So at this point, you should know that React Fiber node, they have this property called memory state. So memory state is there for all Fiber components. It was there for class components where it stores the previous state. So memory state is a property for it to know whether the state has changed, and then like it saved. This is how React saved the previous state for the class component. But it's also there for functional components. So in React Render Reconciler, right, they didn't care whether it's a class component or functional component. It still have this property called memory state. So right now, hooks is just using this thing to save the information of hooks. So then memory state right now is to null because this is the first time you render, so it has nothing. So there's also a variable called current hook that will point to null. So imagine this is sort of like in a global scope, but it's global within a React reconciler. So first time you call, and then you call this function useState, and then useState will create like a hook object here called state, and then you will save the value 0, and then we'll create a setter function, and then these two will be returned here, and then you go to the next line. So current hook will point to a null. So if you start to notice, this looks like a linked list lah. So this is how they store hooks. And then you call use effect. So you will create a new hook object, and you will store the unsubscribe function, because what you return from here is the unsubscribe function. You will store it there, and then you go to the next line, and then you call use memo, and this here, right, you see that use memo pass in a dependency list called counter. So that will be saved in memo, called dependencies, and then memo also save the memory function, and then you return the memory function here, and then you go to the next line, and then you render, and then it's done. But then the next render, when you start to re-render the instance again, you do diffing and then realize, oh, this is the component I already had, and I want to render this again. So currently rendering fiber points to it, and current hook points to the tip of the memory state. So when you call set use state, so state, you point to the state object, right? So they say it's like it's use state. Previously it's null, so you create a start object. Now there's something there, you just return the value and setter of this thing. Okay, so whatever is there, you just return. Then the next line is you go to use effect. Use effect, you will call, because this time you don't pass any dependency list, so you will always call this function. So you call the unsubscribe function, and then you call the unsubscribe function that stored previously there, and then you call this function, and then you save a new unsubscribe function here. Then the next step will be going to use memo. So this list is a new array, right? So this is a new array, and then you will compare with that dependency list, and then do a shallow compare, and realize every item in it is the same. So it will just return whatever is saved here in the memory function, and then it's done. So next, what happened next is that we call set counter. We call this function. So when you call this function, right, what happens is that you will set this value to 3, and then this hook actually has a pointer to point to foobar, the component itself. So it will tell React that, okay, hey, this component has changed, you need to re-render. So we go through this code again. So this time around, the value has changed, so you just return this and this as the return object. So counter right now, return will be 3. So next is that you the same again. You call unsubscribe and then return a new you call this function and then save a new unsubscribe function. Next, this here, right? This list is called a list of item and then the value is 3, right? And then you compare with this. You do a shallow comparison. You notice something is changed. So you create a new memoize function and then you return it here. So now this time around this memo is different. So if you use it here somewhere, you will affect you will cause like other things to have changed. So this is like basically how hooks works in a nutshell. So if you can recall, you can only call hooks at top level, meaning there's no hooks in condition, there's no hooks in loops, and there's no hooks in nested functions. Why? Because if, for example, you have an if case here, and before that, like the first render previously, you don't call this, right? But the next time, when you are in this line, and you hooks points to effect, right? And then you are calling useState, and then React will try to return the value and setter of this thing, and then we realize it's not there, because this is an effect hook, and it can't find what it wants. It will just React will like, huh? What? Right? So that's why they don't allow you to write this, is to prevent cases like this. When you point to this and you want to return, like points to this and wants the subscribe function from here, or points to this, want to get memoize function. It's not that. It's so different. React will don't know how to handle with this kind of case. So you will just say, no, we don't do this. Nextly, it's like if you remember, the second rule is you can only call hooks from React function. Why? Again, this is just a normal function, but this requires when this currently rendering hook and current hook has something there, right, pointing to. If when you call this useState somewhere else in your code, these two points to nothing, right? And you will just have like null pointer again. So I don't know what to do. So that's why you should always follow these two rules, or else this whole logic cannot work. Yeah. So lastly, before I end the whole React hooks introduction, there's one thing I want you guys to take note about it, is that it's about function scope. So you remember that right now everything is written in a function, and then you have a lot of inline functions, and they have scope of the component at the point when they are rendered. Meaning, if you look at this code, okay, maybe it's a bit. Just take note at this place where you have this set timeout here, and then you use a counter from this state, right? And then somewhere later point of the code you call like on alert button, which this one, right? This will set timeout and then get counter. So this function is created at the point where the counter is 0, for example, and then you click, and then you wait like 5 seconds, and then it will call this code. But then if we like assuming the counter will be always, but before 5 seconds you already like set counter to increment it to like maybe number like 1, 2, 3, 4, 5, right? And then the value is different, and then after 5 seconds you want to run this code, right? This counter still points, is created at the scope of the previous render, which is 0 at the time when you call this on alert button callback. Meaning you just have to be aware that function scopes like exist in all these places, and you might somehow encounter weird bugs that you don't know why, and just think that function scope, think in that way, and you might figure out why your bug works happens. So basically that's the end. So summary, hooks is not okay. So this is one more last thing that I want to convey, is that hooks is actually not class component 2.0. You shouldn't think it this way. Although like in the previous slide I've been like saying okay, this is how you do it in class component and how you translate it to hooks. But actually they are not the same. They are designed it differently and they are like, because they try to introduce this thing that you can rewrite in a different way, but they're actually different concepts, have different mentality when they are being used. So class components thinks in terms of classes, and then hooks has like functional concept in it. So there's always things that you can do in class component that you can't do it in functional. Like there's some hooks that they haven't written and couldn't figure out how to write to like cover those cases. And there's also definitely have like some things that you can do it in hooks and you can't do it in class components. So you shouldn't like think as they are like hooks are class component 2.0. And finally, this is a screenshot I got from the React docs, which says you don't have to rush to migrate hooks. I mean, because it takes a bit of like mind shift to think in terms of hooks. And when you think in terms of hook, you might not use the same way of solving a problem. You might have come up with new ideas and new paradigms to solve that problem, and might not even use hooks or whatever. So further resources that I researched on to like put up all these slides. Yeah, that's one of it. Thank you.